Now, is it audible now? Now, is it audible? Yes, yes, yes. Okay, 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 okay. Is it clearly visible to all? Yes, yes, okay. Okay, hello everyone, hello. So in previous class, we have learned some basics of mole concept. In that, I have explained you about molar mass, molar volume, STP, and some other things also. I have given one homework to you. Anyone remember what was the homework? Yeah, it is SATP. Vaishnavi, you are right. Yeah, yeah, SATP. I have given you one question, one homework, that you have to find what is SATP. So please reply fast. What is SATP? Standard ambient temperature and pressure. Very good, Ramya, you are right. It is standard ambient temperature and pressure. Okay. What is the value? What is the value of temperature and pressure when we talk about the SATP? It is 298.15 Kelvin and 1 bar. Yeah, you are right. But name is not mentioned. Okay. Yeah. SATP is actually standard. It is actually standard ambient temperature and pressure. SATP is actually standard ambient temperature and pressure. It is mentioned in NCERT. Vaishnavi, you are absolutely right. Molar volume is 24.789 at ambient temperature. Okay, okay, very good. So, when we talk about the standard ambient temperature and pressure, the temperature is room temperature and it is 25 degrees Celsius. It is 25 degrees Celsius. And if we convert this degree Celsius into Kelvin, what we will get? 298.15 Kelvin. We have learned in the previous class, whenever we want to convert degree Celsius into Kelvin, we have to add 273.15. That's all. So here standard ambient temperature is 25 degrees Celsius, and if I want to convert this degree Celsius into Kelvin, I'll add 273.15. And if I add 273.15, I'll get 298.15 Kelvin. Okay. Now come to the pressure part. I already told you in previous class, standard pressure is always 1 bar. Standard pressure is always 1 bar. So standard ambient temperature and pressure, when we talk about the standard ambient temperature and pressure, standard pressure is 1 bar. You all know that. 1 bar, sometimes we call it exactly. Please listen. 1 bar means exactly 10 to power 5 Pascal. Pascal is the SI unit of pressure. You can say it is Newton per meter square. Okay. And last but most important thing, and it is also mentioned in your NCERT, molar volume at SATP. And whenever we talk about the molar volume and all these things, we talk about the ideal gases only. I told you in the previous class, in the case of real gas, it is variable in nature, because whenever we change the real gas, their interaction will change, value will change. So if we are discussing about the molar volume of gas, we are considering it as ideal gas. Is it clear to you? So molar volume, which is the most important part here, molar volume of ideal gas, and you know that from the previous lecture that molar volume and molar mass can be defined for one type of entity as well as mixture. Okay, so I can write it here, molar volume of ideal gas or mixture of ideal gas, mixture of ideal gas, mixture of ideal gas, mixture of ideal gases at SATP is, please reply, I am waiting. Please reply, I am waiting. 22.4, Ram, you are not correct. 22.4 liter, 24.7 is also wrong. Yeah, name is not mentioned, but it is correct. 24.789. 20, mention unit also, please mention unit. Yeah, it is actually 24.789 liter. And this data is also given in your NCERT. And I have given you homework, and I told you in the previous class, you can see it in your NCERT of states of matter. In the NCERT, it is clearly mentioned that molar volume of ideal gas or mixture of ideal gas at SATP is 24.789 liter. Okay, now please note down this. Vaishnavi is saying it is in page number 144. Wow, that's good. Okay, done, noted. Please note down fastly. Done, noted. Anyone who is still writing, please mention your comment if you are writing. Okay. Okay, I think it is done. Now, this was the homework part. Okay, now we will start some new thing related to mole. I told you in the previous class what is the value of 1 mole. Mole is just a number. Mole is just a number, and it is a large number. And what is the value of 1 mole? It is Avogadro's number, very good, and it is approximately, not exactly, 6.023 into 10 to the power 23. You know that. Okay. Now we will try to understand different formula related to mole. Mole is denoted by symbol small n. Okay, mole is denoted by symbol small n. Now, let's say we have a container, and in this container, any substance is kept. Let number of units of that substance are n, and total mass of all these units is W. So here n is number and W is mass. N is total number, n is total number, and this W is total mass. This W is total mass. Now if I want to know the value of molar mass, I want to know the value of mole, I will write it like this: N is equal to W upon MW. I will write like W upon MW, means mass upon molar mass. Number of moles is equal to mass upon molar mass. Even I can write it like this: N upon Na. Since N upon Na or W upon MW both are reflecting same thing and it is mole, so I can equate them. So number of moles is equal to mass upon molar mass or N upon Na. There is one more formula, and that is V upon 22.4 liter. The thing is that whenever you are considering mass in numerator, you will take molar mass in denominator. Just try to catch the words, okay? Mass in numerator, molar mass in denominator. Number in numerator, Avogadro's number in denominator. Volume in numerator, then molar volume in denominator. Okay? I am repeating it again, okay? Mass, numerator. Molar mass, denominator. Mass, numerator. Molar mass, denominator. Number, numerator. Avogadro's number, denominator. Volume, numerator. Molar volume, denominator. Okay. And you know that molar volume at 0 degrees Celsius and 1 atm pressure is 22.4 liter. Obviously it is for ideal gases. Okay. So you know that molar volume for ideal gases at 0 degrees Celsius and 1 atm pressure is 22.4 liter. The third formula, this one. This third formula, V upon 22.4 liter, is not valid in all the cases. Always remember, first two, W upon MW is valid for all the cases. N upon Na is valid for all the cases. But V upon 22.4 liter, this formula is not valid for all the cases. Sir, then when it is valid, please explain. You know that this volume thing is discussed for gases only. This volume, molar volume, all this stuff is discussed for gases only. So this is valid for gases. And I told you earlier that whenever we talk about the gas, we consider it ideal gas. Sir, why we consider it ideal gas? We also know that. I told you in the previous class, and just few minutes back I explained you, in the case of real gas, data changes with respect to nature of gas. Why it changes? Because in the case of real gas, there is interaction between gas molecules or gas atoms. And if there is interaction between gas molecule, then strength of that interaction depends on the nature of gas. And it changes. And if it is changing with respect to gas, we will not get a fixed value. And here we have to take a fixed, well-defined value so that our problem becomes easier. And in order to do that, we have taken all the gases, or we have considered all the gases as an ideal gas. Is it clear to you? So the thing is, this last formula, V upon 22.4 liter, is valid for ideal gas. And you know that we are considering real gas as ideal gas. We are considering real gas as an ideal gas. There is no ideal gas. Nothing is ideal, yeah, you know. So this third one means V upon 22.4 liter is valid for ideal gases. Even you can say it is valid for ideal gases as well as mixture of ideal gases, because you can discuss all these things for mixture also. Okay. Now one more thing. This is valid at STP. Here we are talking about the old concept of STP. I am mentioning it here, old concept. Because you know that in the case of STP, actually the real concept of STP which is being used today is applicable at 0 degrees Celsius and 1 bar pressure. And you know that at, Navya, you are absolutely right, very good. You have learned the things very, very, very good. I have explained you, according to the recent concept of STP, molar volume is 22.71. According to recent concept of STP, molar volume is 22.71. But in this formula, we are using 22.4. And if we are using data 22.4 liter, it means we are going through old concept of STP. Okay, and this formula is oftenly used in the questions. And always just apply this formula, don't worry. Your answer will be right. Whether it is written STP only, whether it is written 0 atm, 0 degree Celsius 1 atm, 0 degree Celsius 1 bar, don't care. Just solve by using this formula. Because our NCERT and most of the books are still following old concept for this one. If NCERT is following the old concept, then we don't need to change the thing, okay? But we should know what is actual value of molar volume of ideal gas or mixture of ideal gas according to new concept of STP. It is actually 22.71. Because if someone asks, let's say examiner asks the question, what is the molar volume? What is the molar volume of ideal gas or mixture of ideal gas at STP? And they have given you two options. Out of 4, I am discussing about 2 options only, okay? They have given you 2 options. One option is 22.41 liter and another option is 22.71 liter. Please tell me which one will be correct. Yes, Akhila, you are right. Moto G5 plus. Please mention your name here. It will be more easier. Yeah, but Moto G5 plus, you are right. It is 22.71. 22.4 is wrong, beta. Shreya. Yeah, 22.4. Why 22.4? According to new concept, it is 22.7. Redmi Note 9 Pro. Please mention your name. It will be more easier for me. Okay. 22.71 is correct answer. 22.71 liter. You should focus on unit also. So this third formula, V upon 22.4 liter, is valid for ideal gases only and valid at STP, and this is according to old concept of NCERT, old concept of STP. But you can apply this formula for new concept also, just for solving the numericals only. Okay. Now please note down this, and after that I'll give you some questions for make you perfect. More questions you do, more you become perfect. Okay. So please note down. Now, is it audible? Is it audible? Yes, okay. One student, yeah, got it. One student is saying, sir, in previous class, you told me that molar volume of ideal gas is 22.71 liter. I am still saying the same thing. Molar volume of ideal gas or mixture of ideal gas at STP is 22.71. But in the numerical, when they solve the problem mole, they are still using old concept 22.4. If you see your NCERT, they are using this concept, old concept. If you see any other book, they are using old concept. If NCERT is using old concept, if they are still using old concept, then why to change the thing? But simultaneously, they have mentioned the value according to old and new concept. So we should know both the things. Okay, because if we have two choices, one according to 22.4 and another according to 22.7, then we go for 22.7 because that is more correct. Okay, but while solving the numerical, just use 22.4. Got it or not? Please reply. Now is it clear? Please reply. Moto G5, who asked the question, please reply. Yeah. Moto G5 has replies. Please mention your name. Okay. Now we will solve few problems. Initially, I'll give you some simple examples, simple problems so that you can understand the concept. After that, I'll increase the level of question. Before going to that, I will just explain old unitary method thing. When we were kid, we were solving questions like this. We are paying 100 rupee to buy 2 chocolate, then how many rupee we have to pay to buy 5 chocolate. This type of questions we have solved. Or vice versa, they give question like, it is required 2000 rupee to buy 100 chocolate, then if you want to buy 2 chocolates only, then how many rupee you have to pay. This type of question we have done in our junior classes. The funda is, we have to understand the concept of unitary method. Whenever you are solving the problem by using unitary method, firstly decide your path. So what does it mean by path? Means we have to find from where we have to start and at what point we have to end. Or in other words, I can say you have to know what is our initial point and what is our final point. The answer is, initial point is what which is given to you. Initial point is what which is given to you. And final point is what which is asked by the examiner. Again, I am repeating. Listen carefully. Just generally what we do, generally just we start with the question and we start solving, and after few days we get confused. If you want to avoid this confusion, just try to understand the basics. And basic is that you have to find your initial and final thing. From where you have to start and at what point you have to end. And if you want to know that, just focus on one thing. And it is that our initial point is what? Which is given to you. The data which is given to you. And final point is what? Which is asked. Let's say a question came in our mind. Someone is asking, or examiner is asking, how many atoms are present? How many atoms are present in 300 molecules of H2SO4? How many atoms are present in 300 molecules of H2SO4? Now divide this question in two parts. One which is given to you, another which is asked by the examiner. What is given to you? 300 molecules of H2SO4 is given to you. 300 molecules of H2SO4 is given to you. And they are asking about how many atoms are present. Means they are asking about the number of atoms. So given data is about H2SO4, and the question which is being asked inside this question is number of atoms. So what should be our initial point? Because I said earlier, whenever you want to apply unitary method, firstly you have to choose the path. Because if you know the path, you can easily solve the problem. Problem become very easy after knowing this concept. Okay, so here firstly I'll write the formula H2SO4. Now I will try to find my way, my path, my route. Okay. I will say they have given data about H2SO4. Given data is about H2SO4. So H2SO4 will be in left hand side, means our initial point. This is our initial point. Okay. And they are asking about number of atoms. They are asking about number of atoms. So atom will be our final point, means it will be our destination, you can say. So final point will be number of atoms. Final point will be number of atoms. Firstly, you have to find your path. Again, I am repeating, please listen carefully. If you know this concept, you can easily solve so many problems. Okay, in this question they are asking how many atoms are present? How many atoms are present? How many atoms are present? This is the question. Means this is our final destination. This is our final destination. Okay. And they have given 300 molecules of H2SO4. 300 molecules of H2SO4. It is our initial point. It is our initial point. If we know the initial point, if we know the final point, we can easily apply unitary method. Now see. Focus on this molecule H2SO4. One molecule of H2SO4 contain 1, 2, 3 and one atom, 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. So total atom will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. 7. 1, 2, 3, 4, 5, 6, 7. 7 atoms are present in one molecule of H2SO4. Am I right? I'm repeating again, please listen. 2 atoms of hydrogen, okay, 1 atom of sulfur and 4 atoms of oxygen. So 2 plus 1, 3, 3 plus 4, 7. So I can write it like this. 1 H2SO4 contain 7 atoms. And don't use so many lengthy language in between, because why to waste time in writing so many stuff? Just write those things which are necessary. Don't waste your time writing unnecessary things. Okay, so you can say what 1 H2SO4 contains 7 atoms. They have given 300 molecules of H2SO4. So we will say 300 molecules of H2SO4 will contain 300 into 7 atoms. Now our answer will be 2000 atoms. This is our final answer. Now I'll give you one more question. Later on I will give you time to note it down all these things. Okay. Firstly, try to understand more and more questions so you get the concept. Okay. A question is given, how many H2SO4 will be required to have 40,000 oxygen atoms. Okay. Now in this question they are asking about H2SO4. What is the question? How many H2SO4 will be required to have 40,000 oxygen atoms? So divide this question in two parts. One is how many H2SO4 will be required to have 40,000 oxygen atoms. Okay, I have divided question in two parts. Now try to find the initial and final. This is the basic thing. This is basic fundamental of your unitary method. Okay, so initial thing is what? Which is given or which is asked? Please reply. Initial is what? Which is given or which is asked? Which is given? Very good. Now you are right. Initial is what which is given to you. Initial is what which is given to you. Very good, very good. Okay. Okay, given. Okay, all are saying right. Okay. So, initial is what which is given to you. Initial is what which is given to you. And in this, what is given to you? 40,000 oxygen atoms. Means, while solving this problem, I'll say our initial point is oxygen. Our initial point is oxygen atom. And what will be our final point? Which is being asked. You know that. What will be the final point? What will be the final point? Please reply. Which is being asked. Just you have to choose your path. You know the path, you can get the answer. So, how many H2SO4? H2SO4 is our final destination. It is our destination, you can say simply. So, initial is oxygen atom and finally H2SO4. Initial is oxygen atoms and final is H2SO4. Now, put the data, you will get the answer. And for that, you have to focus on H2SO4. You have to focus on given molecule H2SO4. Okay? Now, please tell me, I will start with oxygen and end at H2SO4. Am I right? I will start with oxygen and end at H2SO4. Is it correct? Yes. Now you are right. Okay, okay. All are right. Very good. I'll start with oxygen atom and end at H2SO4 because initial and final is known to me. So I will say 4 oxygen atom. You can see here 4 oxygen atoms are there in one molecule of H2SO4. 4 oxygen atoms are there in one molecule of H2SO4. So I can say 4 oxygen atoms. I can write 4 oxygen atoms here and 1 H2SO4 in that side. Okay. So I can say in other words 4 oxygen atoms are required to have 1 H2SO4. Okay. So if you want to have 1 oxygen atom, how many H2SO4 will be required? 1 by 4. Practically 1 by 4 H2SO4 is not possible. This is just to solve the numerical. You know that fractional molecule is not possible. Molecule will be complete. Molecule will be complete. It will be 1, 2, 3 and 4. Okay. And likewise. 1 by 4 molecule is not possible. This is just to solve the numerical. Okay. Now, I will say like this. 4 oxygen atom, 1 H2SO4. 1 oxygen atom, 1 by 4 H2SO4. How many oxygen atoms are given? 40,000 oxygen atoms are given. So 40,000 oxygen atoms are given. 40,000 oxygen atoms are given. 40,000 oxygen atoms are given. So H2SO4 will be, just multiply 40,000 with 1 by 4. If you know anything for 1, you can find for any given value. Okay, so our answer will be 40,000 multiplied by this 1 by 4. 40,000 multiplied by this 1 by 4. So our answer will be 10,000. This is our answer. Got the point? Yeah, almost all are answering the same 10,000. Initially, few students said it is 1,000, but there must be some calculation mistake. Yeah, 10,000 answer. Very good. Okay. Okay, okay, okay. Now, I am giving you one more question. Question is, how many phosphorus atoms are present in ammonium phosphate containing, how many phosphorus atoms are present in ammonium phosphate containing 800 oxygen atoms? In order to solve this problem, firstly you need to know the formula of ammonium phosphate, and for that purpose initially we have taught you basic inorganic nomenclature. Okay, so if you don't know the formula of ammonium phosphate, you cannot approach the question. That is why sometimes the conversion of name into formula and formula into name should be known to you. Okay, so what is the formula of ammonium sulfate? Anyone please reply. What is the formula of ammonium phosphate? Anyone who want to reply, please? I'm waiting. No. Lenovo, only one person is correct. Okay. Ammonium phosphate is actually NH4 whole thrice PO4. Ammonium phosphate is actually NH4 whole thrice PO4. Now you know the formula. Okay. I'm giving you just 1 minute to solve this problem. Okay. So please try to solve this and reply. Okay. You have 1 minute of time. Okay. Okay. 1 minute is over. Firstly, number of atoms, number of oxygen atoms are given to you, and number of phosphorus atom are asked by the examiner or by myself. Okay. So what will be the initial point? Please reply. What will be the initial point? Initial point. What's, or in other words, I can say what should be written in left side? Oxygen. Okay. So in the formula you can easily find that 4 oxygen atoms are present. There is no oxygen in this side. It is phosphorus. 4 oxygen atoms are present. 4 oxygen atoms are present and 1 phosphorus is present. 4 oxygen, 1 phosphorus. 4 oxygen, 1 phosphorus. Okay. So, and oxygen atoms, number of oxygen atoms is given to you. So, oxygen atoms will be in left side and phosphorus will be in right side. So, initial point will be oxygen. So, I will write like this: 4 oxygen atom and 1 phosphorus atom. Okay, if 4 oxygen atoms are present, then 1 phosphorus atom will be present. Okay. Now, if 1 oxygen atom is present, 1 oxygen atom is present, 1 oxygen atom is present, then how many phosphorus atoms will be present? 1 by 4. 1 by 4 phosphorus atoms will be present. How many oxygen atoms are given to you? 800. So you can write it like this: 800. Let 800 oxygen atoms are present in the given molecule, then total number of phosphorus atoms will be 800 multiplied by 1 by 4, and that will be 200. So our answer will be 200 phosphorus atoms. This is our answer. And I can see clearly most of the students have given correct answer, 200 phosphorus atoms. Now, firstly we will just complete this portion. Please note down, and after that we will solve few more problems of different variety. Firstly, please note down this one. It was the first problem which we have discussed today. Note down, please. Anyone who is still writing, please say yes. I think no one is writing. Okay. Everyone is noted. Now, please note down this one. You have 30 seconds to note down. Okay. Now, note down this one also. Again, you have 30 seconds. Neha is asking, sir, what are the class timings today? My class will end nearly at 2:10 or 2:15 p.m. And other classes are already covered for today. Okay. Now I want to explain you one more thing. After that, I'll give you some different problems. Okay. Let's say I have a formula of any molecule. Let's say I've taken H2SO4. No problem. I can, or you can understand concept by using any one formula. Take any one, whatever you want. Okay. Let's say I've taken H2SO4. In H2SO4, this HSO and 4, whenever you are solving the problem, you can count these given values like 2 for hydrogen. I can mention 1 here for sulfur. Obviously, it will not be mentioned in the formula, but you can consider it because there is one sulfur, na? So the given numbers in a formula like 2 for hydrogen, 1 for sulfur, and 4 for oxygen can be directly used in terms of number and mole only. Please be careful. I am giving you a very important concept. In any given formula of the molecule, these stoichiometric coefficient can be directly used for two things. One is number, another is mole. These things cannot be used for mass. Okay. Likewise, I can say if 4 oxygen atoms are there, then 1 sulfur atom will be present and 2 hydrogen atom will be present in H2SO4 molecule. In terms of mole, I can say if 4 oxygen atom, if 4 moles of oxygen atoms are present, then 1 mole of sulfur and 2 moles of hydrogen will be there. Means these numbers 2, 1, 4 or whatever it is for different molecule, they can be directly used with respect to two things only. And what are they? They are mole and number. In order to explain this concept more clearly, I'll take another example. Let's say I take formula aluminium sulfate. What is the formula of aluminium sulfate? It is Al2SO4 thrice. In this formula, you can clearly find for aluminium number is 2, for sulfur 3 sulfur, okay, for sulfur it is 3, and for oxygen 3 into 4 12, for oxygen it is 12. 2 for aluminium, 3 for sulfur, 12 for oxygen in this molecule aluminium sulfate. Now this number 2, 3 and 12 in aluminium sulfate, this number 2 for aluminium, 3 for sulfur, 12 for oxygen. You got the point? This 2, 3, 12 how came? 2 aluminium, multiply this 3 inside, 3 sulfur, multiply this 3 inside, you will get 3 into 4, 12 oxygen, okay. This number 2, 3, 12, this number, this one, okay, this one, can be directly used for two things only, and they are mole and number. Whenever you solve a numerical, these two things can be directly used. Like I can say in aluminium sulfate, if 2 aluminium atoms are present, then 3 sulfur atoms will be present, 12 oxygen atoms will be present. Or I can say in aluminium sulfate sample, if 2 moles of aluminium is present, then 3 mole of sulfur and 12 mole of oxygen. But be careful. Whenever you are using number, just use number only. When you are using mole, just use mole only. Don't mix these two. Means if this 2 is for mole, then this 3 and 12 will be for mole also. It is not possible that you take 2 for mole and 3 and 12 for number. Or it is also not possible that you take this 2 for number and 3 and 12 for mole. You always have to be in same parameter. Means if you are talking about 2 mole of aluminium, sulfur should be in moles and oxygen should be in moles. If you are taking number of aluminium, then sulfur and oxygen will be in number. You cannot mix these two. Got it or not? I am waiting. Please reply. I am waiting. Please reply. Got it, Shreya. Okay. Anyone who is not able to understand, please reply. Anyone? At least one person who is not able to understand, please reply. I will not move forward till all the students are satisfied. Anyone who is not able to understand the concept, please message here. I think everyone understood the concept. Okay. Now, come to the mass part. Can we use these numbers like 2, 3, 12 for aluminium sulfate with respect to mass? Can we use these numbers with respect to mass? No. Very good. Now you're getting the point. Okay. These numbers can be used for mole and number only. We cannot use these numbers for mass. And that is very crucial part. Because in numericals, we oftenly do a mistake that we mixed or we consider these numbers as mass. Now, I'll give you one question and try to understand the concept, okay? Let's say question is, how many carbon atoms are present? Firstly, I'll give you some simple example, then I will increase the level. Okay. How many atoms are present? How many atoms are present in 4 moles of 4 moles of glucose? How many atoms are present in 4 moles of glucose? If I want to solve this problem, I will focus on our unitary method. Because something is given to you. What is given to you? 4 moles of glucose. And what is being asked? How many atoms are present? So firstly, I'll decide what is my route. What is my path? Route means path, okay? Firstly, I will decide what is my path. So, I'm giving you 2 choices. First choice is I'll start with glucose and end at oxygen. Second choice, I'll start with, not oxygen, atoms, okay, sorry, atoms. So, I'm repeating again. First choice is I'll start with glucose and end at atoms or number of atoms, okay, whatever, atoms. And second choice, I'll start from atom and end at glucose. Which one is correct choice? Please reply. Start at glucose. Ramesh Singh start at glucose. Okay, our starting point should be glucose. Anyone who want to start at atom? Glucose. Vaishnavi is also right. She is saying glucose. Starting point will be glucose. Okay. Okay. Anyone who have different opinion about it? Anyone? Okay, start with glucose. So, how we would come to know that we have to start with glucose? How we will know? Because data related to glucose is given to us. Okay, I said earlier na, the data which is given to you, will be starting point. So, data regarding to glucose is given. So, I'll say, firstly, I'll write the formula of glucose. What is the formula of glucose? I think there is some glitch in the connection. Okay. Now is it connected?
Yes.
I think there is some issue regarding to connection, so wait, be patient. Okay, going live. Yeah, it is not visible here, I think. Okay, okay. Okay, connection resumed. Okay. Okay, okay. So again, we will freshly start with the same question. How many atoms are present in 4 moles of glucose? So if we want to solve this problem, firstly we should know the formula of glucose. And you might be knowing the formula of glucose. It is C6H12O6. After knowing the formula, we will choose our path, means our initial and final point, our starting and ending point. Starting point is what? Which is given to you. So what is given to you? 4 moles of glucose. 4 moles of glucose. So in left hand side we will write 4. Okay. Firstly I'll go through the formula. Left hand side I will write glucose, and right hand side I'll write what is asked to you, and that is atoms. Okay. Left hand side it will be glucose and right side it will be atoms. My path is now known to me. Second thing is that data. What is given, or in what terms data is given? So I am highlighting this thing. If you see 4 moles of glucose, this 4 moles of glucose is given. Means data is given in terms of mole. Data is given in terms of mole. Data is given in terms of mole. So I will say if 4 mole of glucose is present, 4 mole of glucose is present, then how many moles of atom will be there? Count it. 6 plus 12, 18, 18 plus 6, 24 moles of atom. Count the total number of atoms which are present in 1 molecule of glucose. Please count the number of atoms which are present in 1 molecule of glucose. It is 6 plus 12, 18 plus 6, 24. Since I have taken mole in left hand side, I have compulsion to take mole on right side also. It is not possible that I take mole in left hand side and number in right hand side. I said earlier, you have to calculate in same terms. If left hand side is containing mole, then right hand side should also contain mole. If we are discussing in terms of number, then number should be in both the sides, left as well as right. It is not possible that take mole in one side and number in another side. And if you do that, you will get -1. And I think you don't want to get -1. You want full mark. Okay, got the point or not? Okay, very good. So 4 moles of glucose, not 4. I start with 1 now, because 1 mole of glucose, this data is containing 1 mole of glucose. Okay, so change the color. Okay, so I will say 1 mole of glucose will contain, please reply, 24 moles of atom. 1 mole of glucose will contain 24 moles of atom. Am I right? 1 mole of glucose contain 24 moles of atom. Mole should be in either side. If it is number, it should be in either side. You cannot not take mole in left and number in right, or number in left, mole in right. Both sides it should be either mole or number. Got the point or not? So 1 mole of glucose and 24 moles of atom. How many moles of glucose are given to you? How many moles of glucose are given to you? Sir, 4 moles of glucose are given to me. So if 1 mole of glucose is present, it means 24 moles of atom are present. Now if 4 moles of glucose is present, then how many moles of atom will be there? So 24 multiplied by 4 moles. Be careful, it is moles. Moles of atom are present. It is 96 moles of atom. Now what happened? Most of the students give this 96 as an answer. They say, okay, 96 is done, okay. Mostly I found that as a student simply think, okay, 96 is coming and 96 is also given in the option, means 96 is the correct answer. And at that point we are mistaken. Because if we are saying 96 is the correct answer, it means we are saying moles or number of moles are 96. Number of moles are 96. But what they are asking? They are asking you how many atoms, means they are asking about the number. 96 is mole, not number. So here you have to convert mole into number. Got the point? You know the number of moles of atoms. Now you have to convert this mole into number. And if you want to convert this mole into number, you have to use this formula. You know the relation between mole and number. This one, number of moles is equal to N upon Na. Number of moles is equal to N upon Na. You know this formula, where Na is the Avogadro's number. You also know that. So here what we got is number of moles. Number of moles. And we have to convert this number of moles into number. And for that we will use simple formula. And what is that? We will use simple formula, and it is, again I am using some other color for new part. Okay, N is equal to N upon Na. N is equal to N upon Na. Okay, number of moles are 96. So please write 96 here. N divided by Na. Okay, from this you can solve. Na will multiply with 96. Number of atoms will be 96 Na. 96 multiplied by Na. And this is our final answer. Or you can put the value of Na also. And you know approximate value of Na is 6.023 into 10 to the power 23. Or sometimes you can use 6 into 10 to the power 23. Okay, it is not necessary that each time you use 6.023 into 10 to the power 23. You can use just 6 into 10 to the power 23. It is okay, no problem, no problem. Okay, got the point? So whenever you are solving the problem, whether it is very simple or very difficult, doesn't matter. You should always be focused on the problem, and while solving a problem, don't forget what was the asked part. Because sometimes it happens, we are solving the problem, we got 96 with this, I am talking about this example, or same thing happen in other, but data will change. Okay, so we are solving the problem, okay, we got 96 during the calculating, and we see that okay, in option it is 96 is given. Okay, very good, just tick it, because we are in hurry, we are trying to solve the problem very fastly. Okay, we just tick, okay, 96 done, and we forget at that time, oh, it was the mole. 96 is mole, and they were asking about the number. And after that, what happened? When we come out the examination hall, we check the answer key, and we found that different coaching institutes are giving 96 NA for that. And at that moment, everything comes in our head, and we say, oh, I have done a mistake. It was number. Am I right? It happens now. It happens, oftenly it happens. Why it happens? Because we were not careful while solving that problem. Even we were thinking that, oh, it is very easy problem, can be solved like this. And whenever you think that, okay, it can be solved like this, there is very high probability you will get wrong answer. Even if you have a problem which can be solved like this, you should be focused. You should be patient. Because they check your patience, na? You are going to become a doctor. Okay. So, very small thing, but there is no scope of error in your field. That is, I am saying, just solving the problem, you should be very careful. And if you do that, after examination, you will not regret, okay? You will not say, oh, it was number, I ticked for mole, okay? So, how many of you have given answer 96 NA? Shreya 96 NA, KK 96 NA. Anyone who have solved and got 96 NA? Me, sir, 223000. What is this name? Yoga Smart Tab. Have proper name, yeah. It will be much better to recognize you, at least by name. Okay. Ramya 96 NA. Okay. Please mention who have mistaken. They have ticked 96 or they have think that 96 is the final answer. There is no issue. If you accept your mistake, you will learn something. Mostly we learn from our mistake. Vivo 1904. Okay, one person 96. Okay, only one person is there. Okay. So Vivo 1904. Have you got the concept or not? Is it clear to you now? I am asking you, Vivo 1904. Clear, okay. Crystal clear. Your knowledge should be crystal clear. Each and everything which is related to a syllabus should be crystal clear. Okay. Now, please note down this problem and its solution. After that, I'll give you one more problem. Is it visible to all? At least 1 or 2% please reply. Yeah, okay. Please note down. You have 40 seconds to note down. Okay, 40 seconds is done. Now, I'll give you one more question. And in this question, I am expecting that if you solve properly, all of you will get correct answer. But you have to solve properly, okay? So the question is, how many carbon atoms are present in, how many carbon atoms are present in 2.5 moles of 2.5 moles of K4 FeCN6. How many carbon atoms are present in 2.5 moles of K4 FeCN6? Please solve and you have 1 minute to solve this problem, and your time starts now. Okay, 1 minute time period is over. Now, what I can see, most of the students are saying two type of answer, and I am giving you two options. One is 15, another is 15 Na. 15 and 15 Na. It is 15. It is 15. 15 Na. Okay. 15 Na. Second option. Second option. Yeah, you can write just one or two. Okay, no problem. Swati 2, 2230002, Shreya 2. Very good. Okay, okay. Vivo 19042. 222. Very good. Okay, 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 okay. Okay. Now you got the concept. I can clearly see you are able to solve this type of problem, because I think one person said 15, first option only. One person. Only one student said first option. I forgot the name because it is called up. No problem. Who said 15? Is it clear whether it is 15 or 15 NA? Okay, no problem. I'll solve the question, and after that you will get the concept. Again, what is given to us? What is given to us? 2.5 moles of K4 Fe6. Number of moles of K4 Fe6 are given. So, okay, 2091 is saying, sir, they didn't ask number. How many carbon atoms? Please tell me what is this. How many carbon atoms? What is this? This is number or mole? 2091. How many carbon atoms? Name is not mentioned, that is why I am saying 2091, because it is saying 2091. He is saying, sir, they didn't ask number. Okay, if I ask, what is the population of our country? You will tell me the value. In other words, I can ask same question. How many people are present in our country? Oh, someone is saying 140 crore. It is 130. Around 130, okay. My concern is not population right now, okay. My concern is to explain you the concept. If I want to ask about the population of our country, I'll ask in two ways. First, I'll ask like this: what is the population of our country? And I can say, how many people are present in our country? Am I right? If I'm saying how many people, means I'm asking about the number, na? And if I want to ask mole, I'll say like this: how many moles are present? Am I right? So in this thing, he is saying how many carbon atoms are present? How many carbon atoms are present? Again, how many carbon atoms are present? This is number, na? They are asking about the number. Understood? Okay. He said understood. Okay. Anyone who has same confusion? No. Now, what they have given to you? 2.5 moles of K4Fe6. Now you know the route, you know the path. Data about K4Fe6 is given. Data about K4Fe6 is given. And data about carbon they are asking. So our initial point will be K4Fe6 and our final point will be carbon. Okay. Since it is moles, so in left hand side I'll write mole and right side also I'll mention the same thing, means mole. So now carefully just take a look on this formula. You can say 1 mole of K4FeCN6, 1 mole of K4FeCN6 contain, please reply, how many moles of carbon? 1 mole of K4Fe6 contain how many moles of carbon? Please reply 6. 6 or 6 mole. 6 mole. It is 6 mole. Yeah. I have asked mole. Okay, no problem. 1 mole of K4Fe6 contains 6 moles of carbon atom. Got the point or not? You got it. Okay, very good. 1 mole of K4Fe6 contains 6 mole of carbon. And here I want to emphasize same thing which I have taught just few minutes back. If in left side you have written mole, then in right side also you have to mention the same term, means mole. If you have decided to write number in left hand side, then you should mention number in right side also. Because this is the most common mistake which students do. They oftenly do, look, okay, take mole in left hand side and number in right hand side, or number in left hand side, mole in right side. If they are doing this practice, they will get -1. So always remember, mole, number, both the sides it should be same. Either it is mole or it is number, doesn't matter. Okay, got the point? Since it is mole is given to you, that is why I have taken mole. So 1 mole of K4Fe6 is containing 6 moles of carbon. Now I can say 2.5 moles of K4Fe6 contain 2.5 moles of K4Fe6 contain 6 into 2.5 moles of carbon. Okay, if I multiply these two, I'll get 15. So it is 15 moles of carbon atom. Is this our final answer? Answer is no. Why it is not final answer? Because it is 15 moles and they have asked about the number. If they were asking about the moles, this 15 is our final answer. As they are asking about the number, we have to convert this mole into number. Now, I'll just minimize the calculation part. Always remember one thing. Whenever you want to convert mole into number, multiply it by Avogadro number. I am repeating it slowly, okay? So you can understand it clearly. Whenever you want to convert mole into number, multiply it by Avogadro's number. That is, mole, you want to convert mole into number, multiply it by Avogadro's number. Actually, I am talking about the formula n equal to n upon Na, but I want to save your time. So if you know the moles, it is 15 moles. Just multiply it by Avogadro number, it will become number. Multiply this mole with Avogadro's number, it will become number. Okay. So it is 15 moles, so I can write it like this: 15 into Na, carbon atom. That's it. It is our answer. I think you can understand the problem, and More importantly, you should understand the concept. If you know the concept, you can solve the problem of any kind. Okay. Now, please note down this thing. And in next class, I'll discuss some more things about mole. And before coming to next class, please revise everything which is being taught by me in this mole concept basic. Because this chapter, mole concept, is very important. Because in physical chemistry, you cannot solve the problems, you cannot move forward if you don't know the mole and related terms and related problems. So this is basic fundamental topic and which is required in all the chapters of our physical chemistry. So try to revise each and every point, each and every stuff which is delivered to you, and revise other subject also, okay? Because if you want to get a good score, you have to score in all. Okay, every subject, every topic has its own importance. So you cannot ignore anything. Okay, you cannot ignore at least one topic. You have to read each and every topic. You should be very dedicated to your study. Okay, you should be very focused. Okay, so please revise and have a nice day. Thank you. All the best.